Hello everyone, and welcome to Unit 4 Notes, Section 1. Today we are talking about nomenclature. And first things first, what does nomenclature even mean? Nomenclature is just the long word we use to describe our system of naming compounds. And the word itself, the word nomenclature, comes from the Latin word for name and the Latin word for to call. So essentially it just means a list of names or a system of naming. So think back for a second to when we talked about ions. And by now we should all know that ions are atoms that have a different number of electrons, resulting in either a positive or a negative charge. Of course, when that charge is positive, we call those ions cations. And when we're talking about naming things, naming our cations, their name just stays the same as the element. So for example, if I have a calcium ion, that's exactly what I call it. It is a calcium ion. However, anions are a little different. So anions are named with an IDE ending, meaning that we drop essentially the last syllable of the element name and replace it with IDE. So for example, if I have a nitrogen ion, I can simply call that nitride. So go ahead and pause the video here and try and name each of these ions on your own. So the first thing I'm going to do is I am going to look and determine whether my ions are cations or anions. So I'm going to look and find all of my positive ions because those are my cations. My negative ions, of course, are my anions. So let's look through and start naming. Because this magnesium ion is a cation, that's exactly what we call it. It is just a magnesium ion. Same thing with my potassium ion. And same thing with my lithium ion. Okay, now let's look at our anions. So for oxygen, I'm going to take and drop that last part, and I have oxide. For fluorine, I'm going to take my INE, and it becomes IDE, fluoride. With iodine, same thing, INE becomes IDE, and my ion is iodide. So now let's try naming some binary ionic compounds. Binary ionic compounds consist of only two elements, a metal and a nonmetal. To name these compounds, we are going to first name the cation, the metal, and we're just going to use the element name. Then we're going to write the root of the element name for the nonmetal with an IDE ending. So for example, here we have sodium is our metal, chlorine is our nonmetal. So we're going to drop the INE from chlorine, give it an IDE, we have sodium chloride. One more example, so potassium is our metal, iodine is our nonmetal. So we're going to drop the INE ending from iodine and give it an IDE ending. We have potassium iodide. Here we have MgCl2. That Mg is magnesium. Cl is, of course, chlorine again. Magnesium chloride. One more. Here calcium is our metal, nitrogen is our nonmetal. So we are going to name calcium, then drop the ending from nitrogen, give it an IDE ending, we have calcium nitride. Remember, when naming, always name the positive cation first, and then the negative anion. So go ahead and pause the video and try it out for yourself with these. Okay, check your answers. We have lithium phosphide, aluminum sulfide, strontium bromide, rubidium oxide, barium selenide, and cesium iodide. Again, our cation always goes first, anion always comes second, and our anion always takes an IDE ending. So now let's talk about transition metals. Transition metals are a little bit different. If a metal is in group 3 through 12, we are going to use Roman numerals to denote the charge, and that's because transition metals can form multiple ions and they're not easily predicted using the periodic table. So for example, this compound is iron 2 oxide versus this compound is iron 3 oxide. We can also have polyatomic ions. So polyatomic ions consist of more than one atom, but they act as a single unit. So to name these, we're going to simply use the name of the polyatomic ions instead of the anion or cation names, and you'll probably need your common ion reference sheet for this until you get used to these. So for example, this OH right here is a polyatomic ion. We call that hydroxide. So our compound is sodium hydroxide. Here we have ammonium in place of our cation. So we have ammonium sulfide. Okay, go ahead and pause the video here and give these a try. So the answers we should have gotten are silver nitrate, calcium carbonate, lithium chloride, sodium hydroxide, and ammonium phosphate. Okay, now for oxyanions. Oxyanions are a special kind of polyatomic ion that have a nonmetal bonded to one or more oxygen atoms. And to name these, we are going to identify the ion with the greatest number of oxygen atoms. This ion has the suffix ATE, and the ion with the second highest number of oxygen atoms has the suffix ITE. So for example, we have more oxygen in this top ion than in the bottom. So our top ion is nitrate, and the bottom is nitrite.